Before Earth existed, before the sun began to shine, and possibly before the star system that created it had even disappeared, a fragment of ice may already have been traveling through the Milky Way. Last year, that fragment entered our solar system. Now, scientists using the James Webb Space Telescope say it may be up to 12 billion years old. If that estimate holds up, 3I Atlas would not just be another interstellar visitor. It would be one of the oldest objects ever studied this way, and a preserved relic from a planetary system that formed when our galaxy was still young. That is the headline. But the real story is how scientists think they know this at all, because 3I Atlas did not arrive with a label. Nobody can pick it up, cut it open, or directly date the ice. Instead, researchers had to read the chemistry inside the material streaming off the comet and then compare those fingerprints with models of how matter changed across the history of the Milky Way. In other words, this is a detective story told through isotopes. What exactly is 3I Atlas? NASA says it is the third known interstellar object ever observed passing through our solar system. It was first reported on July 1, 2025, by the NASA-funded Atlas Survey Telescope in Rio Hurtado, Chile. Scientists identified it as interstellar because it was moving too fast to be bound to the sun and was following a hyperbolic path. That means it was not orbiting the sun like an ordinary comet from our own system. It came in, passed through, and kept going. And unlike the first interstellar visitor, Oumuamua, this one clearly behaved like a comet. Astronomers saw that 3I Atlas was active, meaning it had an icy nucleus and a surrounding coma of gas and dust. That matters because as the comet warmed up, it released material that space telescopes could study. Scientists could not touch the object, but they could analyze the gases escaping from it. That is where James Webb entered the story. According to the Nature paper published on June 22, the chemistry of 3I Atlas looks unlike anything seen in a solar system body. The most striking clue is its water. The researchers found that the comet's water is highly enriched in deuterium, a heavy form of hydrogen. The paper gives a deuterium to hydrogen ratio of about 0.98%, which it says is more than an order of magnitude higher than in known comets from our own solar system. The carbon isotope ratios were also unusually high compared with typical solar system values and even compared with nearby interstellar clouds and protoplanetary disks. Why does that matter? Because isotopes are like a record of where and under what conditions an object formed. The authors say these extreme isotope signatures point to formation at temperatures of roughly 30 Kelvin or below in a relatively metal-poor environment. 30 Kelvin is brutally cold, only a few dozen degrees above absolute zero. That suggests 3I Atlas formed very far from the heat of its original star, in a cold outer region where ancient ices could lock in these unusual chemical signatures and preserve them for billions of years. Then comes the biggest leap in the story, the age estimate. The paper does not say scientists measured the age directly like reading a timestamp. Instead, it says that when the carbon isotope composition is interpreted using models of galactic chemical evolution, 3I Atlas may have accreted as long ago as 12 billion years ago after an intense early period of star formation in the Milky Way. That is why the wording matters. The safest version is not, this comet is definitely 12 billion years old. The safer and more accurate version is that the evidence suggests it may have formed that long ago. That still makes this object extraordinary. Our solar system is about 4.6 billion years old. So if the upper-end interpretation is right, 3I Atlas formed more than twice as long ago. It would mean that while our solar system did not even exist yet, this icy body was already out there, carrying a chemical memory from a much earlier chapter of the galaxy. That is what makes this more than a comet story. It is really a story about planetary systems that formed before ours and left behind debris we can now study from a distance. The object itself also behaved exactly like the kind of fast visitor you would expect from interstellar space. When it was discovered inside Jupiter's orbit, it was traveling at about 137,000 miles per hour, or 221,000 kilometers per hour. Its speed increased as it fell toward the sun, reaching about 153,000 miles per hour, or 246,000 kilometers per hour, at perihelion. And no, it was never a threat to Earth. Its closest distance from Earth was about 1.8 astronomical units, roughly 170 million miles, or 270 million kilometers. There are still important uncertainties. Scientists do not know the exact star system that produced 3I Atlas. They also do not know its exact size, although Hubble observations placed its nucleus somewhere between about 440 meters and 5.6 kilometers across. And while the isotope evidence is strong enough to make this discovery exciting, the Nature article is still presented as an early access unedited version. That means some wording or interpretation may still be refined before the final edited publication. So this is a major result, but it is also one that should be described carefully. Still, the broader meaning is hard to ignore. This is only the third interstellar object humanity has ever observed, and now it may also be the oldest known example of its kind. Not because we chased it down, and not because we brought a sample back, but because we learned to read its chemistry from across space. In a sense, 3I Atlas is a message from a planetary system that may have vanished billions of years ago, and the message arrived in the form of ice. So the next time someone says a comet is just a dirty snowball, remember this one. This dirty snowball may have formed when the Milky Way was still young, survived a journey between stars, crossed our solar system, and then told scientists something about a lost world that existed long before Earth. And that may be the most remarkable part of the entire story.